Okay. Thank you, Marco, and thank you for having me at Lotico. I'm really thrilled to be talking to you today. And as mentioned, I will talk about the synergies of computational linguistics and the RDF. Initially, my great friend Miriam was supposed to join, but sadly she's fallen ill, so I will do this on my own today, so please bear with me. So what you will see today is a project that we have implemented and been running for the Norwegian Maritime Authority for the past almost 3 years now. No, 2 years, sorry. So this is a project introduction, and we're going to, or I am going to show you how we did it, ups and downs, and some key takeaways from that. So let's begin. Yeah, Marco did a nice introduction on me, so I won't rest on this slide too long. So the Norwegian Maritime Authority, they are responsible for every single vessel that operates in Norwegian waters and every single Norwegian vessel operating abroad. That includes also the personnel on these vessels. They also are responsible for environmental issues along the coastline of Norway, including Svalbard. So what we were asked to do initially for the Norwegian Maritime Authority is to replace their current supervision system, which is a large monolith full of technical guilt and an old legacy system that wasn't quite up to date. So we started from scratch, building a system based on semantic knowledge graphs. And why did they choose semantic knowledge graphs? Well, they needed transforming text, the regulations that they were responsible for, and legislation documents into machine readable data. And they wanted machine readable linked data to do this as well. A lot of actors at the Norwegian Maritime Authority have been following the work done at the European Commission and also in broadcasting companies in Norway, and thought that a knowledge graph would be suitable for their issues as well. So they wanted machine readable linked data and extensive linked data, because we were going to enrich the graph with information not found in the regulation and also external sources. And it was to be shared across different platforms, not only inside the organization itself, but also to third parties. So RDF, being a data exchange format, was a quite good fit here. So there are 2 projects running in parallel at the Norwegian Maritime Authorities. One is replacing the supervision system, meaning translating regulations, the plain text, into machine readable linked data. The other is automatic issuing of personal certificates, where you would conform a set of personal data connected to a sailor against requirements for a particular certificate, for example, for a master mariner or machine engineer or something like that, and then automate that process so the certificates could be issued without too much human interaction. But I'll start with explaining what we did at the supervision system project before doing the automatic certifications. Okay, so this is the origin of information that we had. It's regulations in Norwegian. We did have the English translated versions, but since the English text was a translated variant of the Norwegian text, we wanted to stick to the Norwegian regulations, as those were the source or the origin of information. So luckily, every single regulation has the same kind of structure and layout in the document. We have a title on top here, and we have a chapter title, we have paragraph titles, and we have one or more parts and or subparts. And every single sentence in a regulation is a regulatory requirement. And all our nodes in the knowledge graph, considering the supervision system, was supposed to be a regulatory requirement. So we had a lot of stuff to do, and we started out modeling this by hand. So this is me sitting with the Norwegian regulation and a highlighter pen, translating to English on the fly, as the working language of the graph is English. Well, this is very, very, very time consuming. I think I spent like 80 hours on one regulation, and the NMA, the Norwegian Maritime Authority, has like 200 regulations that we were going to translate into RDF directly from text. So that wasn't the way to go, doing this by hand. So estimated time spent on modeling all regulation was approximately 12,000 hours, which translates into 7 years without vacation. There is a great risk of misinterpretation of information, as I had no experience of the maritime domain before I joined the project. So, and if you have some understanding of the maritime language or the maritime domain, you know that they have completely different words for stuff at sea compared to what we do at land. So there is a huge risk for misinterpretation. And there is a risk for missing out of important information, as we are all humans and we get tired while reading large amount of text. So missing out of information is a great risk. And how would my client, the NMA, be able to maintain such a workflow with doing manual interpretation of data? So we had to come up with something else. And me and my co-worker at the time, in the fall of 2020, launched the hypothesis that it's faster to identify context, concepts, and relationships using natural language processing than manual interpretation. And bear in mind that on this point in time, I had no experience with natural language processing, but I knew it by theory and I knew what it could be used for, but I've never worked with it before. So I told my client that this hypothesis has two possible outcomes. Either it's faster or it's not. And luckily, both outcomes were equally valid. So I was allowed to fail, but I hoped we didn't. So we started building the stack. So we needed some kind of processing of the plain text. We needed to generate the graph. We needed some form of enrichment of the data, as the NMA has a lot of information stored in silo databases around that they needed into the knowledge graph. And we also needed to extract the data because there is a large backend team here working with applications and a front-end team and a UX team and everything. So there is a lot of people relying on the data we generate. So we needed some sort for them to extract the data in a proper way. And this is the result. I'm going to walk you through the different boxes here, but I wanted to show you the pipeline at the beginning. So this is yeah, not too simplified image. It's pretty much what we do. We have a text service at the beginning that flattens down the PDFs and Word files that we can extract either the whole regulation, a chapter, a paragraph, a part, or a subpart in plain text over HTTP APIs. And those snippets of text goes into the NLP module, which is implemented with Python. That produces a JSON object that goes back into the controller service, and the controller service is just the layer controlling all the communications between these microservices. The JSON object then goes into RDF transformation, implemented in Java with RDF for J, that returns RDF back, and that RDF is passed on to top rate H over a insert query. And in addition, we have developed a web service for adding information on checkpoints, because every single requirement is to be inspected. So you have a requirement stating how many light vests you're going to have on a certain vessel of a certain kind. And an inspector from a certified company or from the NMA itself would need to have to go to inspect that particular requirement. And there's a lot of activities connected to this inspections. So we created a web form where domain expert could type in all these activities and connect them to the regulatory requirements found in the knowledge graph. And also smaller data sets like describing trade areas or vessel types and stuff like that are found in some weird old SQL databases somewhere in the world. And we use that to serialize RDF through utter, and that we push right into top rate. So that's graph enrichment. So this is our pipeline running in production, been in production for since fall of 2021-ish. Yeah, so let's go through it. Yes, this is basically what I just told you. But let's start with the text service. So as I mentioned, we could extract the text itself, the plain text of the regulation through the text service over HTTP. And this is sent into the NLP module that is implemented in Python using the framework Spacy. And we also make use of the proprietary software Prodigy for doing annotations. I'm coming back to the annotation stuff in a couple of slides. And the NLP module can be divided in two different areas. The first one is the identifier, which is discovering concepts, context, and relationships in plain text, the regulations. And the identifier will find so-called legal scopes in the regulations. I'm coming back to what a legal scope is in a minute. And then we also have a classifier that is discovering terms in text and classify it. And I know that I wrote relationships here, and that's probably a truth with modifications, because our classifier is a named entity recognition model, but it's only able to discover the subclass relationship. So if any one of you have experience in how to discover something else than only the subclass relationship in text, please reach out and we will probably have a nice discussion. Okay, so the identifier will find so-called legal scopes, and a scope is any characteristic considering a vessel. So it could be the length of a vessel, the gross tonnage, build date, the vessel type, if it's a fishing vessel or a cargo vessel, and so on. And we will also keep the location of the scope and metadata connected to the location as the regulation title, chapter title, paragraph title, and so on. And here is an example of a scope. It's built after 2nd January 1988. So we have build date, which is the scope, that is the path we're noting down. And then we have the context of either before or after a certain date. So we're looking for the context. In this case, it's after. In this case, it's before. And then the particular date. So we're not looking for modeling the whole sentence in detail. We are collecting every single scope for a requirement, combining it with the location it's found, paragraph 7, part 1 for this one, and create a node of it. And every single regulatory requirement will contain a reference to the text itself in the text service. So the backend team can extract the text itself and show that in the front end. But what we are doing in the knowledge graph, we are filtering and searching based on these legal scopes. Okay, so how do we find these scopes? We have built in the identifier on spacey pattern matching rules, and that's basically some kind of fancy regular expressions. So what we do here is finding every single vessel type, and Norwegian is a language that contains a lot of compound words. So we're looking for words that is ending on ship, vessel, or boat. But of course, there is some exceptions to that rule. So we have lekter, which is barge in English, is a word not ending on ship, vessel, or boat. So we have these rules for every single type of legal scope. So we do not need to find new kinds of legal scopes because we already know what we're looking for in this case. The classifier, on the other hand, is going to find terms that we don't know and classify them in some kind of superclass. Yes. So as I mentioned, these legal scopes are characteristics considering a vessel, and together with the location of the scope, that makes out regulatory requirements. Yeah, and this is the JSON output that gets sent into the RDF transformation. The classifier, as I mentioned, is a named entity recognition model that is building a class hierarchy of our classes. And we needed training data in order to start off with the named entity recognition because there wasn't too many trained data sets on maritime data out there on the web. So we had to create some training data, and we had 7 domain experts working together for about 200 hours, annotating random chunks of regulation text. So we see here that antenna is some kind of equipment. So they were highlighting words and classifying them under these superclasses. And the classifier is still working in progress. So we aren't actually in production with the classifier itself, but the identifier has been in production for over half a year now. Yes, and the output from the classifier, quite easy one. It's only the subclass relationship between the entity and the class itself. Okay. So then we have the transformation. So after we have done all these findings in the NLP module, we send the JSON object over to the RDF transformation microservice, which is implemented in Java with RDF4J. And our data model heavily relies on Shackle, and I will come back to why. We have our light ontologies for common vocabularies as trade areas and vessel types. As for trade areas, we also use SCOS, but I won't talk too much about that at the moment. And we have accessible data through Sparkle over HTTP. And I'll come back to that when talking about top rate. So this was me trying to sketch out the flow in the Java code while having a beer at the local pub. I see now that I miss an arrow between the JSON handler and the graph generator. But anyways, we parse JSON, of course, and in the JSON object, we have information about the location of the scope. So that's the requirement object. And then we have information about the legal scope itself and the metrics connected to that. So if it's a length of row scope, we create a length of row object. If it's a build date, we create a build date object, and so on. We have about 13 or 14 different kinds of legal scopes. And then those, and every single legal scope here is containing a requirement object. So all the information I need to generate my graph is found in these scope objects. And the graph generator is basically a collection of methods that will build the graph based on the constraints set in the objects here. So if it's a vessel type, the constraint will be has value. But if it's a build date, the constraint will be a value range constraint or a min inclusive or max exclusive constraint. At the end of the series of methods that builds up the graph, everything is added to a common data structure, a RDF or J model that is outputted back to the one posting the JSON object into this endpoint, outputting the RDF to string. And this is a typical object generated. I have simplified it a little bit because it's a little bit more metadata connected to it, but not necessary for explaining what's happening. So we have the resource itself. We built the URI based on the location. So this is regulation published on 2013, November 22. The number of the regulation is 1404. The section is 7 or paragraph 7, and the part is 1. And it's a requirement, but it's also a node shape. And we have some metadata connected to it. And all requirements contains one or more properties. And the properties are the label scopes. So this scope is build date after 98 January 02. And this is a scope, but it's also a property shape, considering path, which is what kind of scope we're talking about. And in this case, it's build date. We have a min inclusive on the date itself, the metric, and we state the data type as date. So that's our model, how we build regulatory requirements. And it's a quite natural and intuitive way of thinking about regulatory requirements and the scopes connected to the requirements, or the scopes that the requirements are considering. Building is with node shapes and property shapes. And as I mentioned, we're using Top Rate Edge as database and data governance tool. And inside Top Rate Edge, so we decided on Shackle before we decided on tooling. So it's not because of Top Rate Edge that we're using Shackle, but the other way around. So, and Top Rate Edge is very Shackle centric, which fitted us perfectly because we have every single requirement here in the node shape list. And when we explore it, we have the legal scopes here under declared properties, which are easily explainable for our domain experts. You don't need to be a rocket scientist to understand this stuff. And you can expand it here to see metadata and details connected to all these scopes. And you can also filter scopes like compound scopes and regular scopes and get the property groups in a own view here. And everything is clickable, right? And if necessary, you could also edit the source code in a own panel here, but it's also possible to edit the form view itself. And I found it quite easy for our domain expert, at least, to learn this tool and be able to navigate and edit data and adding data. So that was great. And we also, of course, have a Sparkle library connected to Top-Right-Edge, where we could store a lot of predefined Sparkle queries that are in production for the backend team to use to extract data, but also for quality assurance and like nice to have queries. The only thing I'm missing there is some kind of file system for the queries, because we have a lot of queries now. So it would be nice to categorize them in some way, but we have stated some kind of prefixes for the queries so we can sort them out in some way. Anyways, some values coming from implementing this project is that we first of all, we were able to reduce time spent on graph generation by approximately 10,000 hours. We spent 2,200 hours divided on 3 consultants implementing this pipeline in a proof of concept. And that's not a huge amount of time. And it's definitely way less than 12,000 hours. By using this kind of pattern matching, you are able to eliminate the risk of missing out on information, and we reduce the risk of misinterpretation of information, because there might be some kind of structure in the sentences that we aren't catching. I don't know. So I don't have any metrics on how many times we miss stuff, but we have done a lot of quality checks on the data in the knowledge graph and compare it with the actual text together with the domain expert. So we had a couple of days where we do this kind of testing, manual testing, and we do hit very well most of the time. The hardest paragraphs are actually the first paragraph of every single regulation, because they can be quite complex and contain negation. So we have agreed on modeling the first paragraph of every single regulation by hand. But that's a one-time job and won't take too much time. And we're moving logic from software to the graph, which is quite nice, because you then reduce the amount of programming code and lines in the programming implementations in the backend. And lesser software is always better, if you ask me. Okay. So why did we land on Shackle for this case? Well, first of all, Shackle has a quite verbose vocabulary for constraint descriptions. We did do an experiment on modeling some of our more complex cases in OWL and compare it to Shackle. And if we read the turtle for OWL, it's not understandable at all when introducing a lot of axioms and stuff. But by splitting up the data into node shapes and property shapes, and the property shapes having like this very much in with a teaspoon, as we say in Norway, like very verbose and concrete descriptions of what is happening and what we are constraining. That was quite valuable for our client. Yes, and it's data under a closed-wall assumption. When working with law and legislation data, you do not accept incomplete knowledge. Of course, it can happen, it can be there, but I think you would catch that with shackle alone, perhaps, or a combination of owl and shackle, but you would definitely need shackle when talking about law, the domain of law. So being able to express yourself under a closed-wall assumption is probably more apparent in real-life problems than we would perhaps admit to ourselves, but especially in public sector and especially in the domain of law, I think being able to express yourself under a closed-wall assumption is quite important. Yes, as I mentioned, provides an intuitive and natural way for describing regulatory requirements, like the requirement itself as a node shape and all scopes as property shapes. And of course, it's a bonus that TopRate is heavily based on shackle, makes it easier to get the user interface of TopRate to work with us and work with the knowledge graph we are building. So when we have this large knowledge graph with all the data and enriched knowledge in the core base, one of the use cases is a insight portal through the supervision system, where sorry for the Norwegian, but where a ship owner could ask the question, I have a fishing boat on 8 meters built on 3rd of January 98. And in that query, we have 3 scopes. So we have fishing boat, we have 8 meters, and we have built 3rd of January 98. So we will take those 3 scopes and filter on that throughout the whole knowledge graph. So ignoring the specific regulations, like before this insight portal, a caseworker would read the text, right? And you would have a lot of internal domain knowledge on what kind of regulations to look for. But we are searching in all regulations. And fishing boat is found in probably half of them, right? And then the result set would contain only regulatory requirements that fit that specific query, regardless of where it comes from. So paragraph 1 might be from regulation A, paragraph 20 might be from regulation C, and paragraph 42 might be from regulation D, for example. And we also have some risk attributes connected to requirements. Not too much of my area, but I want to mention it either how, because it's some fancy machine learning stuff that I don't know too much about. But anyways, the knowledge graph contains information about what kind of risk models are to be run in the Azure Data Factory sphere. So perhaps paragraph 20 here is considering the vessel type, and based on the history of the particular ship or the history of the ship owner, there is a risk here that this ship owner might have a history with not owning fishing boats. So now he is suddenly asking about fishing boats. That might trigger a warning or an internal risk factor. That so the NMA inspectors have to check this particular requirement themselves instead of letting the ship owner check it. Okay, let's just look at the time. Oh, I've been talking too much. Okay, automatic personal certificates. I'll try to make it brief. But the idea here is to provide a system that would automatic issue a certificate to a sailor asking for it. So if this crab here want to be a master mariner, the master mariner certificate contains a lot of different criteria and requirements. So these certificates are detailed descriptions in Shackle, and they are quite complex as they contain a lot of different alternatives that are equally valid in order to achieve the certificate. So we compare person data with the personal certificates described in Shackle, and the Shackle engine in top right would give us either confirms true, everything is fine, he can achieve the certificate, or if it confirms false, you will get a validation result in return. So we could actually give a proper feedback to the one asking, telling what you miss in order to achieve the certificate. So yeah, I won't bother to read all this, but the point here is that there is a lot of information to be modeled, and there is a lot of cross references to other places in the regulation that also need to be covered. And you could have yes, alternatives like seagoing service is reduced to 24 months if at least 12 months are earned as another position on a vessel of gross tonnage of 500 or more. So yeah, a couple of mention on why not OW. Well, as I've already said, considering the supervision system, OW is too complex for our domain experts, and we don't actually need it because we need the closed wall assumption, and we don't have any need for reasoning. So, but it's possible to express these certificates now. We have done it, but it does require credits in discrete mathematics and logic. And my domain experts are all old sailors, so we can't force them to do that. It would be too advanced for them. And there is a reason that we are hired consultants, right, is to help them with achieving a system and a solution that they actually can maintain themselves in the future as well. So yeah, we have this thing in Shackle where we could do this detailed descriptions of constraints. I may be repeating myself now, but this is at least data example for the certificates, and the certificates are not talking about the legal scopes of things, but we are trying to replicate all requirements in the certificate in Shackle. So here we have the mention of duration of at least 36 months as any deck officer on a seagoing ship with gross tonnage at least 500. So the requirement of gross tonnage at least 500, how can we model that? So in Shackle, it will be a property shape considering gross tonnage with a min inclusive on 500 and the data type unit GT, which is gross tonnage from the QDT unit ontology. And we have a minimum max count of 1, meaning it's unique and mandatory for this particular certificate. And modeling alternatives, I won't go in details on this one. If you're interested in learning more about this automated personal certificates, please reach out to me and we can have some set up some calls or do a discussion afterwards on that. But the point here is to show you that by nesting logical constraint components as or and constraints, we were able to replicate the alternatives described in the regulations. And that was quite nice, and it worked really well with the top-rate Jekyll engine as well. But it required a lot of permutations of possible combinations of like gross tonnage and seagoing service and position. So this is the same sentence again. Duration of at least 36 months. So we have 36 months as any deck officer on a seagoing ship. So seagoing ship is some kind of trade area with a gross tonnage of at least 500. So gross tonnage we already seen, but we have the duration and we have position and we have seagoing or trade area. So let's have a look at the other ones. They're quite easy to set up, not too complex at all. So it's just a combination of these property shapes and how to put them together in node shapes. That is the challenge here in the certificate project. So we have duration, mean inclusive 180 day. We have changed from unit day to time ontology. So this is outdated information. I'm sorry about that. Position, deck officer position is any resource that is an instance of deck officer position class. And then we have bank fishing, which is a factual value. And then putting it together, we have some fine URI as a node shape, and we list all the properties together. So this node shape would express the sentence here. We have a total of 36 to 40 different certificates, and all of them are manually modeled as they are so complex in nature. And also these alternatives, you really need to pay attention when working with this. So what we do then, when we have the shackle graph in place with all the different certificates, luckily in Norway, we almost all of the public sector is quite digitalized, so we can access almost any data through APIs. So we extract data about the person through the Norwegian welfare system, educational institutions, and previous employers to create this profile around the person that is applying for a certificate. And we compare those data, the instance data, person data, data graph, with the shapes graph containing certificate constraints. And we do that with the top-rate shackle validation engine. And the result of that is either issue the certificate to a manual check if there is some warnings that pop up, or a decline certificate. Here is a brief timeline of the main milestones of the project and how many resources were on the project at that particular time. So we started in the beginning of 2020, so this is January and this is December, by training domain experts in semantic technologies and doing initial modeling tasks together with the domain experts. And we had 2 resources on that, 2 junior resources. And in end of May, beginning of July of 2020, we fell on shackle for modeling regulations and certificates, and we started doing the modeling by hand and discovered that this was a waste of time. So we proposed the hypothesis of NLP and started the proof of concept in the fall of 2020, finishing right after New Year's in 2021, going from proof of concept project, and we had 3 resources on projects. We went into production after summer that year. And during the summer, we also had a couple of students working on the SFI specification ontology for us, and I hope we will be able to publish that very, very soon for others to use as well. And SFI is just a collection of classification of components that makes up a vessel. During the fall of 21, we started supporting compound scopes, legal scopes that are connected and are working together. Then we started with graph enrichment and Otter and this web service. And then we moved to Azure DevOps, and that was quite interesting, hosting TopRaid and our pipeline on Azure DevOps and this modern infrastructure with both dev, test, and production environments for TopRaid. A lot of interesting takeaways from that experience. And now from summer and during the rest of the year and next year, we have 2 research sources at the moment, and we are now starting on support for international regulations and supporting previous versions of regulation. For example, for a vessel built in the 80s, it was the regulation text at that time that is still valid for that particular vessel, and not necessarily the text that is published today. So we have to support historic regulations as well. So that is going to be interesting. We have, of course, some challenges for both projects. For example, adding completely new legal scopes. For example, the height of a vessel require new implementation in code. So the client would have to hire consultants to do that work. Training domain experts in TopRaid, Edge, and the Semantic technology stack has somewhat been a challenge, but we also have a lot of good experience with this. The problem is when the client is changing domain experts connected to the project, and you have to retrain people. So we have landed on that the client have to pick a domain expert that is going to be really experienced in TopRaid, Edge, and the Semantic web stack, and being able to answer questions that the other actors at the client might have. So there need to be one semantic node in the organization at the Norwegian Maritime Authority. Collaborating online, the project started during COVID, and the client is based in another part of the country, which is a few hours away. So or that we had to do everything on Teams was a bit of a issue in the beginning, because when you're starting off a project on semantic technologies, you often use the whiteboard, right, and write stuff and strike out stuff and draw all these arrows and boxes and everything. So we had to come up with some collaborative tools in the very beginning, and we actually landed on Web Protege for structuring the main sets of the ontology and working with basic terminology using the comment section on Web Protege a lot before moving into another software. Key takeaways with the projects. I think this is my last slide. When going from text to RDF, natural language processing saves a lot of time. I think I've proved that. And RDF Turtle is quite easy for anyone to learn, actually. I had 65-year-old sailors learning RDF Turtle in a couple of weeks and are writing it in the source code panel. That is quite nice. But a close cooperation with domain expert is crucial. We have at least one domain expert that is also the project owner joining us for daily status meetings every day. So that is crucial because we are not experts on the maritime domain or regulations for that matter. So we need the close cooperation. And as I also mentioned during my talk, closed-well validation are more relevant for real-life cases than perhaps expected. So that might be something to think about. And also mentioned, moving logic from backend to the knowledge graph saves time for development and maintenance. And a RDF tool with recognizable user interface that offers everything is crucial as well. We can't have a lot of different tools for every single little task, like one graph database and another tool for ontology management and another tool for doing queries or stuff. But having everything in one place has been quite important for us, actually. So I think that's it, Marco. So we can open for questions now. I've seen I've used a lot of time.
Well, thank you very much, Veronika. You know, I wanted to give you the time, you know, to learn about your project.
Thank you.
Thank you very much again. So before I ask question, we would like to collect a few questions. If all the participants could either put the question into the chat window or post the question with the audio channel, would be great. And Jay will help me to collect some of the questions as well. So while we collect questions, I might actually ask a couple of things. So I think most of the participants are familiar with Shackle. But nonetheless, I think an important aspect is that you're not using Shackle to validate data necessarily, but to model data.
Yeah. So we do modeling in the supervision part and validation in the certification part.
And was that a natural decision? Did you just was that a decision that came with the tool? Was using TopRate as the platform which has Shackle support, or was it something that you have research investigated?
Well, I have been working with Shackle since 2016 and developed a couple of Shackle engines for previous projects I've been on before it was implemented in the largest tools around the globe. So I had quite the experience with Shackle, and we actually started modeling it, those regulatory requirements with OWL, but we found it a bit complex for domain experts to write the OWL turtle, and using Prodigy as a development tool was hard because it wasn't directly connected to any database. So we had to do imports and exports to a separate database. But the choice of Shackle came from the verbose vocabulary. So when we started using TopRate, everything fell in place, right? Since they are heavily based on Shackle as a modeling language already. But the decision came before the tooling.
Okay, so Jay, I don't see any other questions popping up in the chat or the document. Oh, here's one question. Can you see that chat question as well?
Yeah, I can see it.
Maybe we repeat that, if you could briefly repeat it before you answer the question or
course.
comment.
It's a good question. I often think one of the main benefits of Shackle is the way in which it allows me to think of groups of triples working together to say something useful. Where OWL feels like I'm still at triple level. Can you comment? Yes. Well, I actually feel that you're working with groups in OWL as well. I'm thinking way more set theory when working with OWL than what I do when working with Shackle. But anyways, yes, I think groups and Shackle, and I think that is because it's built up by shapes, right? You have a node shape considering the subject of a triple, and then you have one or more property shapes connected to that specific node shape, talking about predicates and object values. So yes, I think in groups as well on Shackle, but triple level in OWL, not that much really. I think in sets, and everything is like set wise in OWL. Wouldn't you agree, Marco?
Well, it depends on the school you talk to, but that was a question by Adam Kimball. I think that if that's correct, yeah, I read that correctly. Adam, do you want to add to that comment?
Maybe I would just say what really makes me feel that way is to be able to express a Shackle node relationship. You know, that the person lives in a house or whatever, and a house itself already has its definitions. And so it's almost as if we have sort of reference now to this higher order thing, which itself is composed of triples, where OWL, I don't feel actually can do that. I mean, you can by talking about members of sets that themselves are abstract, but I feel like this new level of logical grouping in Shackle is very useful to my thinking about how to turn it into software.
Yeah. Yeah, indeed, it's more native to software developers, perhaps, thinking in the ways that Shackle structured data. I think it's easier for any developer to understand the flow and the logic of Shackle rather than OWL, especially if you don't have any logic from the university on your resume.
And also the kind of rules relationship, right? So the kind of independence, rather thinking of a complete model. There was a webinar, and they again like to divide between the symbolic AI school and the the robotics and the like statistical approach to AI. I actually would like to add another layer, which is Graphe, which is not quite symbolic, right? It's more of a syntactic layer where you can build rules without thinking about the overall logical implications of building your rules, which might end up in a disaster. But nonetheless, it feels easier as a developer, and I agree, to write these rules and then make them operational, in the platform. So it's really maybe a third layer, the Graphe layer, which is not quite the symbolic representation aspect only, but something in its own right. Okay.
Yeah. And Shackle actually allows you to have both object value and literal value in the object position of a triple, and that is not possible to do with OWL. So it's maybe much easier to express the variety of data with Shackle, especially for a developer.
So there is another question by Brice Somakal.
Yeah. About NLP and Spacey, how many Spacey pattern matching rules did you implement? How long did it take to find the right patterns being done in the huge amount of documents? We have 13-ish legal scopes every legal scope varies from 1 pattern matching rule to perhaps 10. The amount of time spent on one regulation identifying all requirements containing legal scopes and those who don't contain legal scopes, we have to take care of every single regulation or requirements, is perhaps half a second. And we can do this in parallel. So we're not talking about minutes when doing all available regulations. It's very fast. And the whole pipeline, like from the NLP to RDF transformation to inserting in top rate, and we insert in a own workflow, like which is kind of a branch in top rate, so it's not going directly into main. The whole process probably takes 1 minute for a regulation.
Latching on to that question, I think you started off by saying that you have an issue with only extracting subclass relationships. Can you?
Yes, that's the classifier and the named entity recognition. So we haven't done too much work in trying to identify other kinds of relationships because I don't know where to start. I have had discussions with people that are really experienced in natural language processing on maybe doing some kind of clustering technique on words that are similar and have and appears in a similar context, and perhaps then label the group that is getting clustered into one single predicate. But I struggle big time in getting my head around to how I would illustrate this out in the system. So if anyone have any experience from this kinds of stuff, please reach out.
Maybe we move this into the community session afterwards, because I'm not exactly sure I understand the issue.
Yeah.
And I think with that, we will close the official part of the session, where we will now stop the recording. And first of all, again, thank you very much, Veronika. We are now having half an hour of open community chat.